Okay. Cup containing 200 grams of water sitting on your dining room table. Carefully measuring its temperature to be 20 degrees, you leave the room, yeah? Returning 10 minutes later, you measure its temperature again and you find that it's now 25. What can you conclude about the amount of heat added to the water? Well, clearly because the temperature of the water went up, right? Well, that just means the room was hotter than the water. And it transferred heat to the water. By some amount, which we can find, because we know the change in temperature, we know we know the mass, we know the specific heat of water. No? Yeah. So you know how to do it?
It's something. Well, it means that something was something contacting the water was hotter than 20 degrees Celsius.
Right.
Something contacting it had to be at least 25 degrees Celsius.
Probably whatever it's sitting on.
Yeah.
That's getting heated from the contents of the room or whatever.
Right.
You know?
Or it's a computer or something and it's warm.
Right. So yeah, okay, so we could actually find it quantitatively.
It says this is a trick question.
I'm not seeing any tricks really in this question. It's
heat added to the water.
Fairly straightforward, yeah.
Well, I don't think you add heat. There's heat is a process of thermal energy transfer, or
yeah,
of internal energy. I mean, the transfer of internal energy.
Right, but at the same time, you know that, I mean, you know, you could do this question many ways, but you know that the amount of heat is just equal, or that you know that the specific heat is the amount of heat required to raise the temperature by some delta T. Right, so and you also know you can make this per gram, because there's a more useful quantity than the specific heat, which is the specific heat per gram. This big C could be C over M, and that's the C we use for water. Yeah. Oh wait, I wrote this backwards. Small c equal big C over M. Right? And so that means MC. So if I plug this here, I get MC equals Q over delta T. And which means Q, this is where Q equal MC delta T came from. And you know, you could figure it out exactly. This is 200 grams. What's the specific heat for water? 4,186. It's right here.
4.186.
Yeah, 4186
joules per gram, or well,
4,186 joules
per kilogram. That's kilogram.
That's capital C.
Yeah. It's 4.
I'm using small c, so
4.186.
Right? Yeah, joules per kilogram, that's correct. Because this is 10 to the right. So I could make this 10 minus 3, 10 3. So this is 4.186 joules per gram, and then the change in temperature is 5 degrees. And so you get the amount of heat added to the water is so grams. Oh, and this is Celsius here. 200 4,186 joules. Questions on that?
Yeah, that's what I got. But it says it's a trick question.
I think it's tricky in the sense. Okay, if you think about this, the specific heat is how much joules you have to add per change in temperature, right? Per degree Celsius. So if you're changing the temperature of water by 5, and you know that the specific heat per 1 gram is 4.186 for every Celsius, right?
Yeah.
So that means if you have 200 grams and 5 Celsius, that would multiply to 1 times 10 to the 3. So that would be 4,186, right? 4.186 times 1,000
Right.
to change 200 grams 5 degrees.
Right. I guess.
Probably that's what it means.